All right, today we're going to pull back the curtain on one of the most powerful technologies out there, machine learning. I mean, this is the magic behind everything from your Netflix queue to life-saving medical scans. But how does it actually work? Let's get into it.
So just think about this for a second. A normal computer program is pretty dumb, right? It just follows a strict set of rules that a human wrote. But machine learning, that's a whole different ballgame. It's about getting computers to figure things out on their own. So what's the secret sauce? How do they actually learn to spot a cat in a picture or detect credit card fraud without a human programming every single possibility? That's the big question we're going to tackle.
So here's the game plan for this explainer. We'll kick things off with what machine learning even is. Then we'll look at the three main ways they learn. We're going to do a deep dive into the most common one, walk through how a model is actually built from scratch, and, maybe most importantly, figure out how we know if it's any good. All right, first things first. What even is machine learning? Well, at its heart, it's a totally different way of thinking about programming. A real shift from the old way of doing things. Okay, the key word here, the thing you absolutely have to remember, is data. See, instead of a programmer sitting down and writing a million lines of if this, then that, we just feed an algorithm a mountain of data and let it figure out the connections on its own. It's the classic difference between giving someone a fish versus teaching them how to fish. Okay, so it's not like machine learning is just one single thing. You can pretty much sort every method into one of three big buckets. Think of it like a family tree with three main branches. And the best way to understand them is with some simple analogies. So first up, you've got supervised learning. This one uses labeled data, which is like you're studying for a test with flashcards that have the answers on the back. Then you have its sibling, unsupervised learning. This time, you've got no answers, no labels. Imagine someone just dumps a massive, jumbled box of Legos in front of you and says, sort these. You'd start finding patterns on your own. And last but not least, we've got reinforcement learning. This one is all about trial and error. It is exactly like training your dog. You give it a treat for good behavior, and over time, it learns what to do. So for this explainer, we're really going to zoom in on supervised learning. Why? Because honestly, it's the one you see out in the wild the most. It's where a ton of the action is right now. Now, even within supervised learning, a model can have one of two main jobs. First, there's regression. Think of this as predicting a number, something on a sliding scale, like what's the price of this house going to be, or what will this patient's blood pressure be? And then you have classification. This is all about sorting things into neat little boxes. Is this email spam or not spam? Is this picture a cat or a dog? So one gives you a number, the other gives you a category. Simple as that. You know, there are a whole bunch of ways to do this, all sorts of algorithms like decision trees and support vector machines. But the real rock star in this group, especially lately, is neural networks. They're kind of modeled after the human brain, and they are just incredible at spotting super complex patterns. It's why they're the go-to for things like understanding images or human language. Okay, so we've got the concepts down. But how do you actually train one of these things? It's not as simple as just throwing all your data into a blender and hitting go. It's a really careful step-by-step process. The absolute key to the whole thing is splitting up your data. So you take the biggest chunk, the training data, and you let the model learn from that. This is like its textbook. Then you bring in the validation set. This is like giving the model a pop quiz or a practice exam. It's so important because it helps you make sure the model isn't just memorizing the answers from the textbook. That's a huge problem called overfitting. And then, only when you think it's ready, you unveil the test data. This is the final exam. It's data the model has never, ever seen before, and its score on this test tells you how it's really going to do out in the real world. Okay, so the model is trained, it's taken its final exam. Now what? We get to maybe the most important question of all. How do we know if it's any good? How do we measure its performance? Well, the first place everyone's mind goes is accuracy, right? It's simple. What percentage of the time did the model get it right? And look, it's a decent starting point, but accuracy can be super, super misleading. Think about it. Let's say you're trying to detect a really rare disease. A lazy model could just say, nope, no disease for everyone. It'd be 99.9% accurate, but completely useless. And that's exactly why we need to be smarter. We need metrics like precision and recall. So precision asks, of all the times I raised a red flag and said positive, how often was I actually right? It's all about not making false alarms. Recall, on the other hand, asks, of all the actual positive cases out there in the world, how many did I manage to catch? This is about not missing anything. And for something like spotting cancer, you would care way more about recall. You'd rather have a few false alarms than miss even a single real case.
There's a saying that just perfectly sums up this whole idea. Because at the end of the day, that's the entire goal. That's why we split the data and use these careful metrics. We don't want a model that's just a good student who memorized the textbook. We want a model that truly learned the material and can apply that knowledge to totally new problems it's never seen before.
All right, so let's do a super quick recap of what we've covered. First, machine learning is all about learning from data, not from a list of rules. Second, it comes in 3 main flavors: supervised, unsupervised, and reinforcement. Third, to build a model you can trust, you have to use that strict train, validate, and test process. And finally, you measure how good it is with smart metrics like precision and recall, not just simple accuracy.
And there you have it. We've gone from the basic question of how do machines learn all the way to how we build them and trust their decisions. And I want to leave you with this final thought. A bigger question, really. Now that we have a handle on how these things learn, what's next? What are the big, important problems that we should be teaching them to solve?